What is command injection?
Command injection is essentially when you have two systems represented here by these two circles.
And anytime when you send information from one to the other, there's the possibility of command injection being involved. Command injection is essentially
Receiving input that violates the expected.
input that a system is supposed to receive. Sometimes the injection attack may not happen directly. So
This diagram kind of illustrates the point. The idea goes like this.
you have system A and it's sending input to system B,
Say system B is accepting.
usernames and passwords, and those are stored in system D.
Later on, say system A makes a request to change their password.
And system P, which is involved in another network, interacts with system D to verify information and change things. So even though system B,
Doesn't respond to the command injection.
but if the username, for example,
Happened to include a command injection attack. When system P interacts with it,
it may launch the attack against system P. So it doesn't always have to happen directly. Where might you attempt an injection style attack?
basically anywhere that accepts input. So this URL bar up at the top.
Might be vulnerable. Modern web browsers are a little bit more secure, but there's potential for that. When you send a web request, what you send up here also can include an injection attack.
All these little buttons for Facebook.
Facebook's gotten pretty good from their earlier days at securing this. But when you click these buttons, it sends some sort of request or input to Facebook.
If you alter that functionality,
You may be able to send a command injection attack. You see bullet points, little check boxes. Same thing, you can alter the ability there. Links, sometimes links,
something that really stands out for an injection attack.
is when you see input like this right here. You might see it on a router or a login or some web pages when it's running software on the computer itself.
In this case, it runs a ping command. This image actually shows a simple example of a command injection attack.
You enter an IP address and then you use a semicolon and then a Linux command. You can actually identify vulnerabilities for command injection attacks within code itself. There are a few functions and methods that are known to be insecure. I'm a bit more familiar with Python, so a little bit of a longer list, but subprocess.call, os.system, os.popen, exec, eval, all of these are vulnerable to command injection unless the input is sanitized. Sanitized input is essentially where you make sure it's within the expected parameters. And there are more functions and methods than this that are vulnerable, but this is a short list. In the server code that is set up in our little virtual environment,
the highlighted sections here with the red arrows is the vulnerable code to command injection attacks.
The code is set up so it should run from Windows and Linux. I haven't tested it on Mac, but theoretically it should run on Mac as well.
You can see the code is using the insecure subprocess.checkoutput.
It's sending some sort of request in straight to the shell. So the basics of a command injection attack.
On Nix systems, so Unix, Linux, and Mac,
knowing a little bit about the shell
helps a lot when putting together an attack.
The basis is essentially the semicolon.
The semicolon means end the prior command and begin another.
Most of the time when you're doing a command injection attack against a Linux system, which includes at least 50% of the servers out there,
which is roughly the number of Linux servers that are running on the internet,
you use a semicolon. There's a few other options here that sometimes you'll use, but not as common. So you have the AND command.
You have an OR command. You have a pipe, which means send input from the previous command to the next.
You can write contents to a new file. These down here,
these operators and formatters are useful to know about depending on the command injection you do.
0x20 is interpreted by a bash shell as a space. So if you're unable to enter in a space, you can use that instead.
Backticks tell a bash shell
specifically to interpret whatever's in between them. So if it's a command, it'll run the command, and the output of that command will then be placed into whatever other command you're running.
This is similar with the $ in parentheses.
And another interesting variable, this is a system variable in a shell, is what you'll use is a $IFS, which stands for Input Field Separator.
When I was testing it out, it turned out to be a tab on the systems.
But this could be defined as a space pretty commonly. On Windows systems, these are essentially identical to the NIC systems. I'm sure there's more.
When I was testing out the command injections, you could perform them on a Windows system as well.
Particularly using this ampersand and commas instead of spaces.
As was hinted in an earlier slide,
sometimes you won't directly see the result of an injection attack. So how might you know if a system is vulnerable to an injection attack?
the first thing to look out for is if no error message is delivered.
It might suggest a vulnerability. This isn't always 100% reliable. If you're attacking a web server, it may be a case of they have a default page that they're sending instead. What other methods could we use to see the result of this? So one is you could compare the response time
of a command that introduces some delay and compare that to a normal request.
So you have the ampersand that's saying and run, and then ping -c means wait 10 seconds. And 127.0.0.1 is the address
of the host itself. So it's telling the computer, I want you to ping yourself and wait 10 seconds. The response you receive is delayed. You know that the command ran.
There's a few other variations of this. You can run other commands such as ping, and then you have your website IP address.
If your web server receives a ping, then you know that the command injection worked. You can try writing the output of a command directly to a file, and oftentimes the server will have a directory available, and so you'll be able to see if you made the file or not.
There's some more complicated methods. You can do DNS lookups, things like that. Let's get to how to perform an attack. I'm now going to open up VirtualBox. The first one I'm going to open up is the injection vulnerable computer. And then this next one I'm going to open up is a Kali Linux distribution.
You need to start by opening up a terminal.
You can do so through the search bar up here as I did before. Since we've already installed the software that we're going to be using, you'll need to change into that directory.
By pressing the tab key, you can auto-complete the command quicker.
And we're specifically running the insecure HTTP server.py.
We will need to enter in an IP address to listen on. You can find the IP address of your host machine in another terminal tab by typing in ifconfig.
And you're looking for the IP address. We set it up already in the prior workshop on
virtual machines. Go ahead and type in that IP address and a port.
We're going to use port 8080. Click enter, and the server should now be listening.
If you want to test that it's running,
you can open a web browser. You type in the IP address 192.168.33.103:8080, which tells it to look for the web page on that port. And if a web page shows up, you know it's running. It's pretty basic web page, so nothing special.
Back in the terminal where the web server is running, you can see the incoming web requests.
Now what we're going to do is we're going to go over to our other machine. This requires Telnet being installed. Telnet
essentially establishes a connection between your computer
and another computer. We're going to go to the other virtual machine we set up, and we're going to type in the telnet command. So it takes care of the TCP IP portion of things. What it doesn't do is take care of application layer protocols, which is really useful in our case.
Type in
the IP address. You might be able to use a URL like www.google.com.
In our case, we're going to telnet to the other machine,
which is 192.168.33.103 on port 8080. You hit enter, and it shows that it's attempting the connection.
If it freezes out, it means the connection's not working.
If you can type things, it means it's working. Telnet is actually a really useful tool compared to port scanners if you're manually trying to probe a system and don't want to get caught.
Port scanners send out a lot of information at once.
While if you make individual targeted connections to see if you can read or write to a port, it's less likely to be detected. So the HTTP request starts out with get in all caps.
There's more to an HTTP request.
The HTTP request starts with get. The server that we're running isn't web
Standard compliant, only doing a very basic version of HTTP.
So we type in get, we're telling the web server to get request. We're going to
type in the expected input, so index.html.
And if we hit enter, we can see that we receive a web page back. It's sending the straight HTML, and you can see all the nitty-gritty details. Okay, now that we know we can connect on that port, we're going to try it again. We're going to try index.html. We're going to use the semicolon, and then we're going to attempt
making a directory.
And we're going to see what happens. So on the web server,
you can go into the www folder
and you type in ls and see if it was made. In this case, it doesn't look like anything happened. So let's try it again. Let's see what happens if we try making a directory without a space. So this goes back to earlier how you can
have bash interpret what you send to it before executing it.
So we're going to connect once again. We do the get command. We give it the expected input. This time, what we're going to do after the semicolon is we're going to make a variable. So cmd
equals $apostrophe.
We're going to do \x20, which stands for the space character. Make directory
\x20.
So another space, and then we're going to type in new. We're going to close it with an apostrophe. Then we're going to do another semicolon, and we're going to echo.
Echo is going to output the contents of our variable. Type in the cmd variable we just made.
And we're going to pipe it into bash and see what happens. Hit enter.
Pretty normal on both sides. In the www directory, we're going to type in ls again, and we will see
that a new folder was created. So we know that command injection is working. In this case, because we can see both sides.
I invite you to try out a time delay command injection to verify that it's working.
So what is the next step after we've successfully performed a command injection?
Well, we're going to try and pwn them, of course. It's time to upload the reverse shell.
I'm going to share the slides really quick. There's a reverse shell provided in the Insecure server software. It's
not that great, but it does work. Each command from this point on is a command injection attack that downloads a dependency of the reverse shell. If you've installed
the guest edition CD, you should be able to copy and paste from your main system straight into the virtual machine. Once you've successfully downloaded all of the required files, you should be able to start it running
using another command injection attack.
If you were doing it on an actual machine, you wouldn't use this particular Python file. You're going to get caught if you use it and it doesn't work that great. But you might use something like NC
or netcat, which is what a lot of actual attackers will use.
Once again, we're going to telnet into the machine. We're going to do a get request. It's a similar format to before, but we've changed it slightly. So we create a variable cmd3, we define it in between the dollar symbol and the apostrophe, which is telling the interpreter to interpret this. So it interprets this, it changes the \x20 into spaces and stores it into command 3. And then what we're doing is we're taking
command 3 and we're piping it into bash. But if you did that alone,
what you would find is that it doesn't work. And the reason it doesn't work is because the Python software that's running will actually interpret that
unless you close and send it something else.
So we put in another semicolon, and it doesn't matter too much what we send, but we're echoing, in this case, hi. So the Python script has something it can throw an error on. And if you hit enter,
it should run the reverse shell.
Now, if you take a look at what's going on in the server on the back end, you'll notice that an exception was thrown. The reverse shell has a very rudimentary password to use it.
It should be running now.
The reverse shell was pre-configured for a connection on Telnet, same IP address, 192.168.33.103.
At 8081, so port 8081.
You hit enter, and it's made a connection to that port successfully. You type in enter_get in all caps and press enter, and you'll notice that the server has received a request.
In effect, on the server,
you've created another thread that's now running your reverse shell. And if you type in a command like ls, you'll suddenly see
the results.
There's a few more things that you can try and figure out on your own. Are there any questions?